that took me a minute, or more like 5 minutes. But I think I finally have everything set up. I think I got everything ready to go. So, initially, I was going to do some circuit board soldering, but I accidentally threw some parts out by the looks of it, because I haven't been able to find them all afternoon or evening. So instead, I'm going to do a bit of a redesign for my LED tower lights. Initially, I was 3D printing these, and then I had molds to tint resin, epoxy resin, and cast it. And then realized instead that I found a seller on AliExpress that sells tower lights for a very good price. And this is the seller. I have not purchased any of them. I have not tested them yet, but they are a fairly good price. You have everything from 5-layer down to a single layer, both with and without buzzers, in the voltage ranges you could want. And yeah, so I'll probably get a few of these. Welcome, Frank. So I'll probably get a few of these tower lights at some point, but in my small little workshop, these things are way oversized, so I still want to use my parts that I have for my tower light, which is 180-degree version. The only thing I'm going to change is, instead of making it one single circuit board, I can make it a panel of LEDs and cut my costs down and make it easier to assemble. It adds a little bit of wiring, but that's better than trying to make one giant circuit board and all that stuff. At least I think so. Because I can lower the cost by keeping it under the 100 by 100 size. Although, I think about it, if I look at the model, might actually be able to fit it. I don't know, I'd have to play around with it. But I'm going to focus on the controller first anyways, which has a bit more to it. And for like the past hour, I've been thinking of what to put on the controller. So I'm making a controller that can generically control the tower light, both my version and something off the shelf. So 6 channels. So I'm going to use the WS2811 to control MOSFETs, which will use single wire interface from an ESP. I found a module on AliExpress that offers Ethernet. It is fairly handy, saves me space, saves me time soldering, and it is actually cheaper than buying the raw Ethernet chip at the moment. So I built that in my CAD program so I can easily drop it in. Trying to find it. Here it is. This module here, Ethernet, and then I can simply plug it into the controller, and so I can offer Ethernet or Wi-Fi support on the controller. And then if somebody really wanted PoE and you're not running a super big light that uses a lot of power, you could get away with something like this. So this would give you 12 volts, should be able to supply enough current, and can give you PoE support fairly easily by using this other Ethernet module and a 2.1mm jack that I'll add. That's kind of the overview. See how I make out. Let's see. To save myself time, I can go into some of my old designs and grab schematics. Oh, and then the other thing I wanted to add to this was OLED support. My current one has an OLED with a real-time clock module, as well as just a regular temp sensor, which is kind of handy. And then the time is updated to stay in sync better. It's updated through Node-RED, which also works very well for daylight savings. And initially I was trying to find parts to put on my board, but they're all out of stock. And Adafruit actually has a better price on their modules, and they offer it with the quick connector. So instead I have the quick connector ready to go in the CAD program. I found it and downloaded it, and that way I will have the ability to just plug in those modules that I want, and if somebody doesn't want them, they don't have to add them. So let's see. First portion, we need the ESP with all of its regular connections. We are going to use IO16, I think. I'll have to double check. Name. Nope. Name. There we go. IO16. Set it to flag. And at power supply. Power supply. In order to make it work with 24 volts, the WS2811s would have to be on 5 volts. Which means I'm going to add an AMS chip to go from 5 volts to 3.3 to run the ESP. I don't know, if you start plugging in extra modules, you're probably going to run out of current. The flags, I can show you that in a moment. I'm going to delete that, and instead, so on my other screen I have another window open, and I'm going through parts and just copying and pasting from other projects. Saves me time from having to redo everything when I have a schematic that I know is correct. Let's open this one. This one has a proper voltage regulator, so I'm going to do 2 regulators. This one is 3.3 volts. I'm going to copy it, and then what I can do, right click, replace. Let's find my library. It's either going to be in this one, I have a feeling it's in my second library. Just check the name. 2596. Do I only have it in the one style? I'm just gonna have to change the name of it, I guess. They're both the same pinout. This LMS regulator comes in a variety of fixed voltages, and I believe they do offer one that's changeable. But for my needs, let's change the name. Nope, value. Change the value. 5.0. And we don't want it going to VCC anymore. So here's the flag. So I've clicked the name tool, and then I click the net that I want to change. So right now it just goes to its default. Normally place labels already selected for you. So I'm going to change it to 5 volts. And up at the top you can change it to just being regular text, which if I were placing it like that I might leave it like that, but more often than not I turn on the flag. If things are, let me turn on the grid. For the normal grid, size typically defaults to 0.07, which if you're doing it like that, you're not going to be immediately able to place something on the next line. So I typically set it for 0.04, and that lets me do multiple flags in short succession. Unless I really need something to stand out, then I'll go larger size and I'll just space it away from everything. But for this, I can simply do that. To make things easier later, I'm going to change this one as well. 3.3 volts and 5 volts. Actually, it's even easier. 3v3. So that's the flag, and everything else is the same for that. I do, however, LCSC. I want to check. Go to my order history. I just ordered a bunch of parts. Five volts. Just want to see what the input range on the regulator is. Should be something like 30 volts, I think. But rather be safe than sorry. Ah, 37 volts. 57 for the high voltage version. But I don't think I bought the high voltage version. I think I got the regular one. Yeah, I got the regular version. So 37 volts. More than suitable. 3 amp step down. Yep. Okay. So that's power. I do want the power socket, so this. I think I'm going to change it. Instead of 12 volts, let's copy VDD over. And then I think that's that. What else? I need the WS2811s. Can't remember where. Is the right board? Here we go. This is the driver I'm going to use. DN, DO, yep. This has to all be changed. Let's remove that. That is right. Is this the right part? And then need the MOSFETs, which I'm going to use the same ones I used on the LED controller. A little bit overkill, but they're rated for like 8 or 10 amps or something, so more than apt for any situation. The MOSFET, I need 6 of them. 2, 3, 1. Those are all going to be pulled up. Select those, copy them over. Now the only thing I'm going to change don't need that, don't need that. This can go to there. Let's move this over. Split. There we go. I'm gonna change the name for this. Everything else is fine. Oh, let's fix. Now V in. Now if I'm using 5 volts, that changes its spec. Let's see. What is the spec for 5 volts? 100 ohms. I don't think I have 100 ohm in my kit. Looks like I'm ordering another port. Let's put in... Considering I already have an order going, it's best to order now. Because then it combines shipping. 100 ohm. 0603. Apply. On sale too. Very good price. Well, let's buy 1,000 of them. It's only $2. And oh, that's why I'm getting a handling fee. Secure checkout. Oh, gotta log back in. So on this, channel 1, channel 2, channel 3, channel 1, channel 2, channel 3. So you'll see here with the label, I'm using the right mouse click to rotate these labels. CH2. See, with the sizing of them, I can fit them all right next to each other. Channel 3, CH4. And get my ports in. The right size. Okay, let's change the value to 100 R. And 1,000 resistors on order. Good. I really hope they finish moving the warehouse soon. My goodness, it's slowing things down. Pretty much every item I've selected is 3 days before it sends it out, instead of their normal 24 hours. And the shipping prices have gone up. Although I think it's their peak time right now in China, which is annoying. Sure beats the pricing for shipping from my local post office. I think that's everything. Data in, data out. Let's use... Not sure if the resistor array or singular resistors is going to be best for these MOSFETs. What I do know is I should buy some more of those terminal blocks. My goodness, I'm finding more things to buy. Yeah, the terminal blocks that I used on the driver so I can do this. Wait, that's 4. No. Let's get the 2-pin version. Nope. There we go. 1. And let's move the extra label. 2, 3. That's those connections. I don't have very many of those terminal blocks on hand. So let's get a few on order. Do a little math. So I got let's get a few of these. These are the better ones. I have cheap terminal blocks on hand, but these ones are very, very nice. There we go. Okay. I keep distracting myself. So what I need to do is... Oh. So These are all going to ground. I was hoping to do this schematic fairly quickly so that I could go into PCB view and show off whatever tricks people have questions about. Let's change the name of these. So 5 volts. And then the only other thing I know I need those are the right ones. Copy. Value 4.7K. 4.7K. That's gonna be for the I2C lines. So that's going to so for this one, it will have the ESP on board, and the way I've been flashing them is with RxTX and a ground connection to a programmer, and then it has onboard buttons for flashing. Once it's already flashed, I can have OTA code on it, similar to the current Smart Hub. And then from there, it's not hard to do what you need to. There'll also be Ethernet, and I haven't tried it yet, but I'm pretty sure I can make my OTA code work with Ethernet as well. Although a device like this might be worth having linked with the rest of the acer system. Part of the reasoning would be that I've designed this as an accessibility device for myself. So the white on my tower is my doorbell. My doorbell currently makes no noise whatsoever, which of course causes people to either keep hitting it or knocking at the door really loudly, which is useless because all the bedroom doors are always closed. No one can hear it. So I have Tasmota bulbs to replace my 2-year bulbs outside, because I really hate 2-year's system and it's terrible integration with Node-RED and all that kind of stuff. I just haven't taken the time to put the bulbs outside and set everything up the way I want to, because right now it's running just a standard timer. But I actually have a Node-RED flow set up so that it can turn on with sunset and sundown. And then partway through the night it dims them a little because you don't need them on. I just haven't set everything up. And then one of the functions I want to set up is I have a sensor for my door as well, so if the door gets opened it can brighten the bulb right at the front door so you can see what's going on. And then once the door closes it can dim the bulb back down, but if the doorbell gets pushed it can flash the bulb a certain color to acknowledge that it has been pressed. Yes. So I'm using a 5-layer tower as my main one, which I plan to put them in the garage as well, so that if I'm doing work out there, again, I can see what's going on. I have it designed for a 3D printing tower, and that's going to have 2 3D printers that I can network. So those 2 3D printers will have their own lights, but they're only going to be the 3 colors, so the red, yellow, and green. So the way I plan to set it up is white is always going to be my doorbell. Blue is kind of my general notification. So my current tower right now has a mini OLED, which lets me see time and temperature data for the room it's in. So I'm going to design this controller that I'm working on right now to have a plug so you can put an OLED in. And then blue is the color that I normally use for like a general notification. So I have a few keypads in the house for different locks or functions. And if a master code gets inputted, it triggers that blue light just so that I know, because myself and staff are the only ones that are supposed to use it. Staff aren't here very often, so if somebody's using it, I know that there might be something going on, and I should figure out why somebody's trying to use it, or the fact that they've sat there and tried to figure out what the code is. Green is currently green, yellow, and red are not set up to do anything in my current setup. Once my 3D printer is hooked up to Octoprint, if my 3D printer is on, light will be green. If the 3D printer is running and it's hot, it will go yellow until the temp goes back down to normal. If it fails a print, it can turn on the red light. I'm also going to put a smoke detector inside the 3D print chamber. If that gets triggered, it's going to flash the red light. And then I'll probably put a smoke alarm in my garage as well and link it to this system as well. So if I had done work down there, normally if I'm doing something that has the potential to create sparks like welding or something, I don't leave the garage for an hour after doing so. Just try and prevent anything from potentially catching fire. But even still, I'll put a smoke detector there just in case. And then stuff like my soldering iron and my hot glue guns, I plan to hook them up to Wi-Fi enabled plugs or SON-offs. I haven't fully decided, but I'll hook them up to it. So if they are on, yellow light will be on. Yellow light will essentially be something hot is turned on. I also want to modify the controller for my soldering oven to also, I'll just use 5mm LEDs in the panel of it instead of a full assembly. And that way it too can also communicate with the system. And instead of having its ridiculously annoying beep. So that's kind of the idea behind the tower lights. Let's see here. This is gonna... That's better. A little nicer to read. And then I think the only other part I need is this connector here. This is a 4-pin JST connector that matches Adafruit and SparkFun's Quick System. It's a 4-pin JST SH series connector. And I'm gonna have to look up the pinout for it. Originally, I was just gonna put some pin headers for modules, like the BME sensor and whatnot, but then I realized it's probably just easier to have the quick connect. And one of the other things I want is the real-time clock module, and that's a fairly easy part, but it's not in stock, so it's easier to get the quick version of it, which is in stock, and it's actually cheaper than the raw IC chip. Right now I'm just trying to find the pinout for this quick connector. Documents, schematic. So pin 1 is supposed to be ground. No idea. Let's open the board file and see. So my board file shows this as pin 1. I want to compare. See the one. So this is the one Adafruit has, and it shows pin 1 over here, which is wrong from what I have. Let me open up my order and check the pinout. I'm hoping my plug is upside down and that I can still use it. Let's see. That shows that up top. No, it does not look like it. So it looks like I have a backwards footprint. Okay. When the part arrives, I will probably buy one of Adafruit's adapter cables, and obviously probably buy the modules at the same time, and probably buy those connectors from Adafruit as well, just to compare to the ones that I buy. It's a little extra cost to have to buy them, but I'd rather do it and double check that it is correct. So I'm going to treat this as being backwards, and if I... Hello, Dodgy. So I'm going to treat these pins as being backwards for now, and if I do confirm that they are backwards, I will go in and edit it later so that they are the right way around. So this should be ground, this should be power, nope, ground. connection there. So L and then this is 3.3 3v3. I'm actually doing a redesign of my LED tower system. Initially I had done a design for it, but then found a cheaper option for an LED tower light. So it seems silly to redo or get PCBs made to build a tower light when it's cheaper to have one pre-made from China. These are JST connections that match Adafruit and SparkFun's quick connectors. So instead of putting certain modules that I may want on the board, it's a lot easier to just add connections for it. So the few things that I want are the BME sensor. Initially I was looking at just using the BME 280, which is humidity, barometric pressure, temperature, barometric pressure, and humidity. But I found a new one that they sell, which is the BME 680, which has temperature, humidity, barometric pressure, and VOC gas sensing. So I wouldn't mind playing around with that one and seeing what that one is like. And then OLED support and real-time clock module. And I could add a real-time clock right to my design, but I cannot get the ICs for it, and it's actually cheaper to buy Adafruit's version with the quick connectors on it. So people could pick and choose if they wanted extra sensors on this controller board and have it run a regular standard tower light. And then I plan to redesign my 180-degree tower light, because that one I can't get a cheap version of, and mine is a bit more compact than a standard tower light. So I'm going to redesign the LED board for that to be compatible with this controller, saving me parts and cost and whatnot. Instead of having numerous items being built, it's much simpler to wire up. So you got ESP. The other part I need is the Ethernet. So, Ethernet support, which reminds me, actually, how many pins is that? 1, 2, 3, 4, 5, 6. Should buy some 6-pin headers. I can plug it in instead of having it soldered in place. There we go. Number of rows, single. Oh, reset. That is what I want. Yeah, it is. The BME 680 really is has quite a few options. Oh yeah, I also want to wire up my garage door. Put some read sensors for when it's open and closed, and I want to try and see if I can't 3D print like a gear that can mesh with the chain drive, so that as the door is moving or closing, you can know when it's actually moving. Feel like it would be a handy option. ESP8266 actually on this one. I'm not doing a 32 on this board. Actually, yeah, I have this button panel. So originally I was going to put together another 2 of these button panels because I have a shipment to go out to someone. But accidentally threw out some parts. So I gotta wait for parts for it, which I keep adding more parts to my order. Pay, processing, and I think that's done. Yeah. And gotta find a power adapter. Sorry, ears. I yanked the cable for my microphone. Okay. Let's not drag that cable. I think... So, if I power this switch panel, it's connecting to Wi-Fi, connected to Wi-Fi. So it actually tries to go white briefly, but it connects to MQTT way too fast that it tends to skip the white half the time. Only rarely, if it hangs up briefly, you'll see white on the buttons telling you it's trying to connect. For this smart switch, I actually plan to go back through its design, and I want to also try and add this Ethernet connection to it. The other thing I want to add is a lux sensor, and try and see if I can't squeeze in a temperature sensor on it as well, so that you have more options. So you'd have an LSC connection, you'd have Ethernet, and you'd have Wi-Fi. So it's like triple redundant. And then you'd have a light sensor and temperature sensor. So you could do pretty much anything you wanted with it. And it's 3D printable, so it's fairly easy to maintain, or you can custom color it or whatever you wanted to. You can do engravings on it as well, if you wanted, and sit there and polish it. Polishing the 3D prints can take a while. So with this button panel, I have it set up through Node-RED. I can actually push a button and the color lights. So it does the 3 of them right now. And then if I go into my Node-RED, I don't have it turned on, but a lot of my devices have what's called a flash channel, or flash topic, which is a very generic topic to flash an LED. So if I turn that on and then I go back in and I double press a button, it will actually start flashing the LED on the board. Now the part you can't see is the LED tower is actually in sync because of that flash topic. So just kind of as a test, I can control my LED tower through my smart switch at the moment. Eventually, almost all of its control is going to be automated, except for like doorbell. It waits until I hit the reset button. The LCD screen can be turned off with another button for when I'm sleeping, so it's not lit up or anything. And the blue light, which is just a general notification light, so I can send a message to the LCD and have the light lit up. That one is also reset with the reset button. Green will stay on as long as the device is triggering it. So if I leave my 3D printer on, but it's not running, so it's not at temperature, then green light will be lit, telling me I've left something on, which will also be useful for doing stuff in the garage. The 180 degree tower, yes, I can sell it. I expect the 180 degree tower to be a lot more niche. You're better off probably buying this, but it is fairly large, which is why I designed a smaller one. Now I do plan to get a resin 3D printer, so it might bring the cost down a little bit to make the 180 degree version versus trying to make it manually with resin and stuff. But the controller, yes, I'm definitely willing to sell the controller because it's relatively straightforward and it makes it easy if somebody wants to control them. Yes, it pretty much is a general system awareness. And there is a protocol for how tower lights are normally set up. And I have that saved somewhere on my computer. But the only 2 colors that are non-standardized for their performance is blue and white. Hence why I have them as custom uses. But, yeah. Let's turn on that. And let's go back into here. Finish off the schematic. Channel 1. Yes. So here, let me get another view of it again. It's only set up to be 180 degrees, so it only lights on the one side. It's built into the 3D print. And the current makeshift electronics for it. Trying to watch the YouTube feed and it's got one heck of a delay. And then this is the display on it right now. Which I'll probably end up 3D printing everything once I build my work desk and whatnot and move things around. Just a little. Especially, well, the new version is slightly larger than that one. But I could make it smaller again because the reason I had made it larger was my 360 version. I wanted them both to be the same size. Yes, you could add a buzzer. And this controller has 6 channels, so one of them could be used for a buzzer. Which I may, for my garage ones, I may add a buzzer to them. And yeah, for 3D printer, you could use it for that. But yes, you can wire in a buzzer if you wanted. Actually, let me see here. Which reminds me, if you're gonna use a buzzer, so on my current tower, it's hot glued to the side and it's mounted on perf board. Oh, you're being snarky there, Aaron. But yeah, right now it's on the side of it. Once I build my desk, I'll have space to hide it inside a wall or wherever. But it wouldn't be hard for someone to mount it inside of some sort of case. Because typically a tower light has a bit of a cable coming off it, so probably going to mount a control box near wherever you want it. Let's copy this. Actually, you already have power. Connector. Yeah, no. It's not. And at least with my design, you should be able to run it off a PoE module like this. So if you run an Ethernet connection, then you could very easily power it up and have constant connection to the tower. Which is another reason I'm redesigning it, because originally I was just going to have Wi-Fi, and I figured, why bother if I can fit this itty bitty module in place. So some towers are 24 volts, some are 12 volts. So I'm designing this to work on both. If it was just going to be 12 volts, then it'd be a lot easier to wire up these WS2811 drivers. But then you wouldn't be able to use 24 volts, so just to make sure that it's compatible with all applications, I'm adding an extra regulator so that everything can work nicely. And actually with these regulators, you could run it up to 37 volts. So yeah. And this controls, the way this will be set up is it controls ground side switching. So whatever power you're putting in as V in is what your lights would run at. Which my towers are set up to run at 12 volts. Actually, I think this one in front of me is 5 volts at the moment. But when I rebuild it, it will be set up for 12 volts. Right. I just realized I don't have something turned on. Wondering why some parts aren't showing up. Let's go into my libraries. Let's turn that on. Let's try this again. No? So if you plug my controller directly into a PoE switch, nothing would happen. The Ethernet adapter that I'm using has no connection for PoE, so it wouldn't do anything. That injector is from standard AF PoE standard, so 48 to 57 volts, and we'll step it down to 12 volts. Which then you use the barrel jack that adapter has into the barrel jack on my module, and it would power it. But if you plugged Ethernet with PoE directly into this controller, nothing should happen, because it won't be able to communicate to tell power to turn on from a switch. Right, libraries. Use all. Let's try this again. There we go. No. It's not the right size that I want, though. That's the one I want. So I'm not entirely sure if I need 2 of these pins for this module to correctly work. So I'm putting these solder jumpers in place so that I can remove them or disable it if I need to. And these particular types of solder jumpers are solder paste ones, so the stencil, when I lay it down, will put solder paste directly over them, so once it goes in the oven it connects it, so I don't actually have to sit there and solder them by hand. and they make it in 2 variations, so you could not have to do it manually, but if you want to, it's an option. And they have it for 3-way solder jumpers too, and you can make it put paste down for those as well. Ground. Connect that. Three v 3. And now I need to find the spec for that ESP. ESP8266 pen out. So GPIO 16 should not be used on that one. This one can go to reset. So I'm not gonna use IO 16. So we have, which ones do I have available? I got IO2, 15, 14, 12, and 13. 14 is the serial clock. In case you're wondering, I'm looking at this document, which shows me the different pins and what they're potentially used for. So I'm referencing that to set all these pins up. Acer. Master in, slave out, although apparently we don't like those terms anymore. I know they're changing the standard for it, or at least trying to. I can understand why, though. Yes, that is the one that I need to change. Chip select. I always come up with a different name for these. Slave select, chip select. There's a few other variations of it. What else? Interrupt and chip select are the ones that I'm missing. So 14, 12, 13. Oh, it recommends chip select on GPIO 15. Which GPI 2. Now see, I don't know if this interrupt pin is... I need to find out if this interrupt pin pulls low or if it goes high. Because... Using the I/O, the only one left is I/O2, which is pulled high at boot and it fails if it's pulled low. So I need to double check that. Let's see here. W5500 module. Yeah, I want to find out for this. The other option is GPIO3, which is the RX pen. But if you wanted to upload firmware, you'd have to undo that solder jumper. Although granted, once firmware is on it, I'll have OTA on it, so it wouldn't really matter. Which, speaking of which, there's already new versions for the Smart Hub. Now up to version 1.02, which just smooths out some of the UI and Node-RED output. And then there are new node flows for Node-RED on GitHub that let you test everything, as well as give you a very basic dashboard output. I'm sure more will get added eventually, and then version 2 will eventually be done as well. Now they have reset connected to an actual GPIO pin. Doesn't make any sense. Really annoying when you can't find what you're looking for. It's also a different module that I'm finding wiring for. Find a pinout. Can't find a actual wiring example. That is very annoying. Oh. Well, let's look at library. It doesn't do anything fancy, so I can't tell. I cannot tell what that interrupt pin does. It's likely gonna turn into a try it and see what happens kind of thing. Theoretically, I could either put a transistor or a diode in place, but I have no idea which direction it needs to travel, or if the board has some sort of pull up or pull down on it. Now granted, I probably won't be buying this board for a little while. I may leave it until I actually build my desk so that I have a better way of filming and doing things. Kind of my plan is to try and do the desk sooner than later, especially for stuff like the Smart Hub version 3. So I'm not using a direct chip, I'm using a module. Show you here. I know Tinker has one, so I might see if I can convince him to wire one up and load an example on it. But this is the module. It runs the W5500 Ethernet chip, which is the same one on the Rack 32 controller. Just this is a little nice plug-in module, saves space. This module is actually cheaper than the W5500 chip that's on it. It's underneath the circuit board here. So it's easier for me to buy this module and solder the 12 pins on it than it is to buy all the supporting capacitors and stuff that it has underneath and the Ethernet socket and all that. So for now, I think I'm going to connect this to IO2. It has the jumper, so I can disable it if I need to. And if I find it interfused, then I'll have to find a different way of wiring it. Although I do have one of these modules coming from AliExpress. He does use the chip, but I have no idea how it's wired on the module. I assume it'd be fairly close, if not exactly. But I'd rather see the actual module and double check how it's wired. And I have the module coming. I'd expect to get it within a couple weeks or so. And I don't plan to immediately produce this board, so it gives me time to test it once the module arrives, that is. So, if anything, I can probably just switch to the ESP32, to be honest. But would be rather overkill on this situation. Oh. There we go. The only thing left, I need pull-up resistors for all of these channels. Trying to decide if I want to use a resistor array or if I want to individually solder them. What did I do on the controller? I did a resistor array, didn't I? I did. Normally you would do a pull down for these, but the way the WS2811 driver works, you need them pulled up to work properly. Copy. I labeled that wrong. Channel 1. And then ground. And I think that's everything that I need to make that work. Simplify this a little bit. text. Okay, that should be what I need. Ethernet. Grab a quick connector. And the only thing left is the MCU. I want to make this a little more compact. I think I do. I always hate doing lines. This program. Oh goodness. Let's do it like this. I really need to get a mount for this microphone so it's not in my way all the time. I can go there. Ethernet and let's move this over. That, and next we have our outputs. There we go. All nice and organized. Relatively straightforward. Save. And let's do the part that I'm sure Frank has been anxiously waiting for. Turn it into a circuit board. Ooh, what's going on Discord? I've had Discord hidden because I knew there'd be lots of stuff. Let's see here. Oh, I know Ben sent me an email. Yeah, that's fine, Frank. Is there anything in particular you wanted me to show in the board in terms of how to do or what to do? I may, but I can still show some of it now. Just making note of what Ben wanted changed on GitHub. So Polygon is this tool in the corner that literally is a polygon. And right now it's set to the top layer. So I can go in and, oh, that's really big. Let's change the grid. Turn the grid on. Normally I work in millimeters, so 0.5. So I can take this line, and you can change its thickness, but it won't really change what's going on. And I can go around this board. And then it now tells you what do you want the signal to be. So let's set it to ground. And now it turns into a dashed line. Now, when I hit rat's nest, oh, it didn't do anything. Does a part need to be there? Yeah, this part's got a ground on it. I hate when people put the label of their names right in the spot for it. There. So, that now filled ground in. So you don't have to run a trace for ground. It will essentially do it automatically. So it's now connected this ground section of this voltage regulator and its 2 pins to ground through what are called thermals. So these thin traces are thermals. If you wanted to get rid of it, you could use a polygon tool and up at the top turn thermals off and say I just want to get rid of it for this one part. I can go around this one part, name that ground, and then hit rat's nest again, and it will completely fill it in. Now, the size of this regulator, I would not want to do that in that section. That will take forever to either solder or desolder because of how big of a ground plane that is. Now granted, if the circuit board was smaller, you might get away with it, but even still, this is a large regulator. You would not want to do that. For these pins, maybe I want the extra capacity, although granted, this is such a small distance for it to go, it's almost negligible. It's mainly just to make soldering easier. More often than not, on something like this, I will try to make a big trace on it, just to ensure it has a good connection. The other option is you can, so let's take this ESP for example. You don't normally want a ground plane right next to this antenna. And I also don't run traces underneath it for signals for anything. So what I can do, and normally I would do this before I run an auto router so that the auto router does not try to run something underneath this wire. So what I can do is polygon, but this time I'm going to go to a different layer called T-restrict. So T-restrict is the top layer, B-restrict is the bottom layer. So T-restrict, and I do this for both sides of the board. I can go back to that in a minute. So for T-restrict, what I can do is I can go around this section and it automatically fills it in, and it doesn't request any information when you do the T-restrict. So it's now filled in a section right where the antenna of this ESP would be. If I hit rat's nest, it removes ground fill from that section. Now, the other thing it won't let you do is run a you can manually do it. You can try and run a trace. See, doing it manually, it won't let me. It doesn't like me trying to put a trace there. It also won't let you do it with the auto router. If I ran the trace and then did this T-restrict, it would complain that I have trace there. And I would do this for top and bottom so that there's no ground fill in this spot. This is not what I did on your shield because there are traces there for the shield. I just wanted to isolate your KNX from the main system. So I did something different there, and I'll show that in a minute. But I can delete this, and rat's nest, it will fill it back in again. So let's remove that. Let's go back to here. So the difference of what I did here, if I click polygon and I'm set top layer, right now thermals are off. So if I draw around this and tell it to be the ground plane, because you can make it either VCC, ground, you can make it whatever you wanted. So if you needed a big trace, instead of manually doing it, you can make one polygon and do a nice power trace or whatever, a custom shape for something. I'm telling it it's ground. And then I hit rat's nest again. Instead of having those small traces, which are called thermals, connecting the ground of this voltage regulator to the ground plane, it's filled it all in. But those thermals, especially on a part like this regulator, are essential. Otherwise, you will not be able to solder it correctly because the heat will try and dissipate way too much. So I removed it with Control Z. So the other thing you can do is when there's a polygon, if you're tired of looking at it, I have it around the edge, so I can come over here and I can use the rip up tool and it removes it. Hit polygon again, and it comes back. Whip it up. Or I can hit delete, and it will start deleting it, and then it's completely gone. What I did to isolate the section on your KNX shield, let's take this regulator as an example. I can go in and go on the polygon tool, and I can come along and come part way let's do a funky shape while I'm at it. Come back around and ground. So it's now filled that section in. Now, because I did the full board on the KNX shield, I'll come over here and I can meet up here. Typically, you'd want some overlap. If there's not, I had to do something funky on the KNX shield because there was a section that didn't have an immediate ground connection, so I had to offset these two layers so that it would actually work properly. So come along here, come back down, over to here, over to there. And I can tell it to be the ground plane as well. Now if I hit, oh, actually I made a mistake. Let's try that again. That would have filled everything in, and it's not what I wanted. Got that ground. Okay, now if I hit the rat's nest, oh, there's no parts for it. Let's grab another one of these regulators and put that there, and this JST also has a ground connection, so let's put it over there. And just to make things a little easier to see, let's turn off that. Okay, so we have some parts there. I hit rat's nest, and it now isolates that one section. And that is how I did the connection on the KNX shield. I broke it up into multiple polygons so that I could isolate a section. And when I did that recent polygon, I still had the thermals turned off, so the ground pin that's under here is fully visible, or fully covered in copper, which that's a small connector. You can probably get away with it. You're probably not going to like it on something like this regulator where it's filled everything. Makes sense? Thanks, Aaron. Hopefully that made sense, Frank. Sounds good. See you later, Frank. Okay, so time to see I'm very curious if I can fit that. Ah, almost. Ooh, deja vu moment. It almost lets you do it. I'm very tempted to try and route this like that. Because presumably you're using it one of two ways. You're either using the Ethernet or you're using Wi-Fi. It's hard to say. Because if you use the Ethernet and then try to use Wi-Fi as failover, the Wi-Fi is probably going to have signal issues. So, to avoid that, I'm just gonna put it separately. Power connection. Lots of power regulation. I'm gonna try and see if I can't fit everything on one side of the board to make things easier to assemble. Right now, just trying to find the right layout to use. Might work even better. So the way I'm thinking of wiring it is you have ground straight across, and then ground can come around as well. It's gonna be a little trickier for this ground, but we'll see. Because the input power can come across to each one of these regulators. 3.3 volts for the ESP and the I2C connections. It makes sense. Diode. This diode goes with this one. So a lot of these parts, I changed the grid layout, so a lot of these parts aren't snapped to it. So when I go to move it, I can hit the control button before I click it, and it will snap the part to the grid. And I have a function of Windows turned on, where if I hit control, it shows me where my cursor is. Very handy. Very, very handy. Especially with triple monitors. No, that's button. This diode goes with this regulator. And you got the output capacitor. Which probably gonna fit it like that. And this capacitor. Making it very wide. Let's see. Let's try and place these MOSFETs. Well, these are in the wrong order, so that doesn't help. It's number 6, so that's that one. We do it like that. And So these sides, this side of the pins goes to there, which is the ground for your light. And then you got 3 pins for ground, and then you have your signal for controlling the MOSFET. And then to control those MOSFETs, I have WS2811s. They offer 3 channels for RGB, although we're not controlling red, green, blue LEDs, we're controlling different colors. And I have a 6th channel which we could use, which someone can use for a buzzer if they wanted to. Which I'll probably program into it a quiet mode where you can tell it to hush and not trigger silent mode, or not trigger a siren if you didn't want to, say for a newborn baby. Though a buzzer isn't really the best thing, you'd want some sort of speaker or audio board. Something that can play a nice chime or something. Yeah, play something that has a nice chime or even a voice of sorts for announcements versus just a buzzer. Buzzer just tends to be annoying. Goes off at the wrong time and you end up ripping it out anyways. Audio can get complicated. There's a few ways to do it. You could use an MP3 shield, you could use an audio effects board, which Adafruit sells an audio effects board. And it actually works very well. I've used it in a few projects, but it depends what you're going for. Yeah, it looks like I can make this fairly compact. Actually, it's hard to say. If I... So this one works nicely. Put them back to back. Might work. Trying not to make it so wide. 100 millimeters tall, which is fine. and I can shrink it more. These can actually overlap because the connectors themselves don't go far outside this footprint. Just has a really large border around it, which is annoying. It's this power regulator that I have to figure out how I want to wire it. Plus I need mounting holes. Let's put some temporary wires in place. Ground. VDD. Ground. Now, need this diode. It can connect between there and there. Now you got 5 volts that needs to come out. Now, so this one's a little easier. You can just route the 3.3 volts up and out. Probably gonna pass it through a via. Actually, no, I don't need to. Sneaky way to do this is to move this diode up, and ground can come right through here. And then 5 volts comes up and out. Ground. 3.3 volts comes up and out. Ground. I'm gonna change all these traces in a few moments once I settle on a layout. The power connector can go there. What's that? Can I get it to 75? See if I can't make this 75 millimeters wide. Let's tight to this capacitor now. .3 ground reset. I think I can get away with it. Ooh, yeah. Now, got the programming header. Pretty much just want to smack it here because it's a quick shot. To these pins. And then you have this, which, to be honest, I could go down, cross, and then this. It's not ideal, but this can work. No, can't. So ideally, you have 3.3 volts coming through. The other option is, oh, I can't run that like that because that's right by the antenna. Let's see here. So if I did it double-sided with surface mount parts on both sides, it'd save me some space, but I also want to make assembly easier. It's a heck of a lot easier to do it all on one side. Let's put the stop in place. So that I can't run traces here. I do. Just takes longer to assemble it. Probably just finish this one the way it is, and then I typically end up copy and pasting the files in Windows Explorer and making a second version to play around with layouts. And that way I always have a backup copy as well to revert back to. Yeah. Overall, size isn't bad, especially like if you compare it to if you're using a full-size LED tower. This is minuscule in comparison, and in all likelihood, you're probably gonna mount it in the wall, so you wouldn't even see it. It's how I would mount it. So for PCBs, most fab houses, if you can stay under 100 by 100, you save a lot of money. If you're doing very small stuff, like the boards that I have to do for my 180-degree tower version, I'm thinking of just making LED boards and miniature ones. They would be like 20 millimeters by 48. Those I could get panelized and still stay within the 100 by 100, and that would save me a lot of money. So if I get 5 boards panelized at the 20 by 48, I could get a total of 10 mini boards on one board. Yeah, once you pass 100 by 100, the price jumps significantly. My Smart LSC is like 215 by 100 and something, and it's like $100 for 5 of them. It's kind of nuts. .1. All these traces are going to change in sizing and stuff once I get everything set up. Hmm. That's that connection. I don't have 3.3 volts set up here. Silly me. 3v3. Oh, that's way too large. And I gotta change it over here too. Everything else looks correct. Save. Save this. Okay, where does power go? That's handy. Well, I labeled some of these connections wrong. Let's go back to the schematic. Ethernet. Serial clock is GPIO 14. IO 14. IO 15. IO 13. That should be better. I need to step away for a minute, and I'll be back to finish fiddling with this. Oh, wrong view. Main view. There we go. Okay, I'm back. Right. Just trying to route. Where does this one have to go? That's annoying. What I can do is rotate this around. And I can actually go through here. No, I can't quite do that, can I? Let's see. Through here to there. Okay. Now this one. This might be the section where I have to use some vias, although granted, none of these are critical. The only one that is critical is this 3.3 volt line, which I'm thinking, let's rip all this up. In all honesty, I want that 3.3 volt line to be the biggest line. And I'd rather it be direct rather than looping around like it is, because that's going to be a bottleneck there. So, but so far it looks like I am going to be able to run the wires the way I want / need to. It's just a matter of setting everything to the correct size. Power goes up. Plus I have all these resistors to put in place. Oh, I got these too. To there. And let's see. That can go... Probably gonna go like that. And... let's set... I can actually run the power trace along the bottom here. So... now I need a hole. Properties 3.3 drill -10 -8.5. There we go. I'm gonna create a circle. Properties, set it to T document, which means it won't show up in the files you export for the manufacturer, and it also won't show up when I export it to CAD. But it's there because it can tell me the size of the bolt head. So I set it point 0.1. Radius is 3.15. The radius of the screws I normally use are 6mm. So if I don't put anything within the gray ring, I know that the bolts will be fine. I'm thinking I'm gonna move all of this up so that I can fit the power jack over, put a hole here, put a bolt here, jack in the middle. Yeah. Let's move that over there. Put the power jack here. Power is gonna run up the side like that. And then let's reset that. Let's move the bolt hole. Okay, now we go. Nope, move. Move command. So capacitor there, capacitor here, which means power can come right up. And then we do regulator 1. And then, actually, oh, got these the wrong way around. Although, thinking about it, I wonder if I can fit them like this. Save myself some space. Oh, yes. There we go. Properties 31, 37, 164. Yeah, that uses up space rather efficiently. Actually, this can come down a bit. Because this line here is the line where it actually is. This outer box is just a box. Should probably remove it, to be honest. Yeah, now they're at the same level. Let's double check. 4 by 28, that's fine. Properties. Actually, 3.5 by... Wait. Calculator. 75 minus 3.5 is 71.5. I'm gonna do the same for the outer ring. 71.5, 3.5, there we go. Let's fix this one. 3.5. 28 by 3.5. There we go. So there's your two mounting holes. At least in that corner. And then can move a lot of these parts back down now. There we go. And that makes sense. This makes sense. It just... Let's remove these labels. Out of my way. Trying to think here. How I want to wire this. Probably gonna move these back a bit later so that I can put labeling on each channel. Save. What's this resistor for? R6. Oh, it's part of the drivers. And these are for this setup here. So let's whip this up. And it's that one. That is part of that. SDA comes right across. There we go. I can connect like that. Ideally, if I'm doing programming there, I want these buttons to be close by. Delete and delete. And then these resistors, well, first mistake, one set of those are supposed to be pull-ups, not pull-downs. There's the first issue. Five volts. Otherwise they won't work right. If at all, to be honest. This goes with the I/O. Also with I/O. And then this one is over here. And then those are all with that. Okay, let's see if we can't squeeze some parts together. Um, IO2. That one is best to be here because you got a reset line and then it has to come all the way across. Tell you, learning to solder a resistor over here is like the greatest thing ever. What size is this one? 0603? Yeah. Very, very handy. $12, $13, $14. So it's best to be here. I think that's all the parts. Wow. It's actually a decent sized board. Right now it's still set to the 100, but it's 75 millimeters wide. Which, once I do this top section, I think I will get it a decent size. Let's move that out of there. And it is indeed dodgy. Thank you very much for the compliment. Let's try it. Let's see if I can make it square. 75 millimeters square. I don't think I can, but I'll give it a shot. I have a feeling it's going to be probably about 80 millimeters tall. Which still isn't bad, I don't think. And I do plan on rounding these corners. Almost every circuit board I do now, I don't bother putting sharp corners like this. I round them off. Let's see. Oh yeah, no, I'm not fitting that. Okay, so it has to be 80. Although it might have to be slightly larger than 80, to be honest. Let's get the text out. Let's move that up and 6. It does. But in terms of form factor, I don't want to be sending a larger board than necessary. Like, granted, if you really needed to save space, you'd probably make it like a 4-layer board and put parts on both sides. But obviously, isn't needed. But don't need to be sending a 100 by 100 board if you don't really need to. Oh, I'm gonna need to space that out more. There we go. Now we got port numbering. I can get in with MOSFETs. Gonna have to move those buttons, which is fine. They're not massively critical to anything. Where is center? 75 divided by 2, 37.5. line. See you later, Dodgy. Thanks for hanging out. That should be center there. There. Those ports are aligned to center, and then if I move this, properties 3.5, 80 minus 3.5 is 76.5. I go properties 76.5 and 3.5. That's that one. And we can copy and paste it over to this side. Where we go properties 76.5, 76.5. Oh no, what did I do wrong? Properties 76.5, 76.5. Oh, nope, that's wrong. 75 minus 3.5 is 71.5. 71.5. Nope, wrong direction. 71.5. 71.5, 76.5. There we go. So, MOSFETs. So I think the drivers are gonna sit over here, and then the buttons I can fit over here. I think that's how it's gonna work. Nope. Let's move that up. 66. Yeah, that's fine. Okay. Buttons are in place. $20, 67. Nope. Let's back it off a bit. 66, that's fine. So 20 by 50. No, let's go up. 59. Yep. So 31 by 66. Properties 31 by 58. No, What was it, 59? Yeah. 59. Properties, 43 by 59. 43 by 66. There. That aligns those nicely, and then these resistors, I already know I'm gonna have to change the order of them. Actually, it's probably gonna be easier to wire them right next to the drivers. And I'm right, it is going to be easier. So I'm going to link them right across. And then this is for that pin. This one's for this driver. This is for the main one. It's for this one. Actually, it's gonna be easier to do it like that. Then the capacitors. Put it like that. And this capacitor. I still need labeling over there. Oh, no. So I'm going to move that down. Move that over there. I'm actually going to change those capacitors for a different footprint. Let's see here. Replace. I'm going to use this one instead. And replace, and use that one as well. And save, and come back here. And the reason I switch those is it gives me a little buffer, which does make it a little easier. Puts the same buffer as the resistors, which just makes it a little easier making sure you have space between everything. Now, text, ground, and then VN. Looks better like that. These capacitors are backwards. This one should be with that. That one should be with that. Let's merge that like that. Get rid of these labels. And then resistor there. Snap it to the grid. And then we can move that like that, and that be like that. There. That keeps it a little more organized. I plan to redo a lot of these labels. So. There we go. I can fit everything nicely. So, for routing, let's switch over to mills. And the reason I switch over is because I know my trace width's better when it's in the mills section. And I also have this handy little reference guide when I need to refer back to things. So it shows me, it actually shows me in millimeters as well, but it shows the mils. Standard trace I typically try to do is 24 mils, and then work around from there. And then power traces, I try to make them as big as I possibly can. So let's start with these MOSFETs. Yeah, I'm not gonna get away with that, am I? Let's try 75. let's see here. Let's give it a little more space. Yeah. Definitely overkill for this application, but probably can't hurt. Okay, and now these grounds probably gonna have to be 50. Yeah. These are rather oversized vias, but then again, I want to make sure it can handle the power that you try to throw at it. Yep. Looks good. Let's fix that. Yeah, looks about right. And then set the vias back to their normal size. Now, ground, I can leave it alone. Normal trace. Let's go smaller. actually realizing what I can do for this resistor is if I move it down here, I think I'm still gonna run into an issue. Let's see. Because I need that signal to... no, because I'm gonna have power on the way. Okay, so that's fine. I'll leave it for now, but this one can go like that, and then I can come up like that. This is the signal here that I'm wondering what to do with. Let's have that connect like that, and is that the only power I need? Right now I think it is. It's only 5-volt power at least, and... these traces all need to be larger anyways. Stop using small traces. Large trace, right. Can I get away with a size 50? Oh, I think I can. So we got 5 volts. I actually need to switch these around, don't I? I think I do. Yeah, 'cause set back to millimeters. Properties. 41.2, 44. Let's give it some more space. 47.5. 32 and 40.2. 40.2, 72. Ooh. Let's double check. 40.2, okay. 40.2, 73. No, 71.5. No. 64. Yeah, I didn't think that was gonna work. 67. 69. 69.2. Yeah, 69.5. Yeah, okay, that's better. Yeah. So now what I can do is I can take the net up and around. 5-volt line can connect to there. 5 volts comes up, connect. Ideally you don't do a 90-degree, so let's do that. That's excessive, so let's fix that. Can't hope to do that. And I'm actually probably going to do a polygon for a lot of this. Ground can connect. Okay, think I got that all settled. 5 volts is over there. Ground, ground. Now 3.3 volts comes over to here. So let's give them some, oh no, that's too large. Switch over back to mils. 32. Yeah, I can get away with that. And then the signals I can do in 24, I think. Might be too large for trying to pass through this resistor. Let's find out. Yeah, okay, so next size 20. I'm actually wondering, RX TX, I can pass him up this way, couldn't I? So I move it like that. Oop. Because now I can't even fit it through there. Let's go to a 16. Let's see here. Line 16. Let's see, can I make this work? Oh, I can. Awesome. Oh, silly me. Put that back up. Come through here. I still can't fit through there. 12. There we go. Let's change all these other ones. So short distance, it's only sending data. I'm confident that a 12 will be fine. See if I can't fit this up through here, and I can. Awesome. With that, I So NeoPixel line will have to go over to here, and it will have to come up to the buttons. But let's change this. So that nope. Nope. There. So now we have a good ground connection. Set the via back to its normal. Okay. Thinking here. There's a ground there. It doesn't need to be much because it's a 10K pull down. So I'll leave it for now, but this power trace can go there. That is ground. I want a bigger trace coming to the ESP. There. To ensure that it can handle any peaks, big power trace. I'll actually probably swap it for a polygon, to be honest. I want to try and use the polygon a bit more, or the polygon tool a bit more. Just not really needed. That trace is more than enough. Actually, what I can do and 3. Not really needed to have that connected if it's not actually connecting to anything, and less likely to short from IO13 to it. And then accidentally give it a really strong pull up. Now IO16 is not used. So I'll leave that like that. Could actually switch IO13. Let's do that. Just realized where's my cell phone? Okay. There. Save. Come back over, and now what I can do. And the reason I'm doing this is it gives me more space around the pads to either run a VIA or go around everything to loop back around if I needed to. Reset, probably just easy to connect it across. Can't get that around, and I do like the 12, so let's move the module over a little. And now I can fit this track how I want to. IO14. Supposed to go all the way around that. Ground can connect at the bottom. This VCC is 3 volts for the Ethernet. So no, I'm tempted to go larger on that trace. Let's move this over. I think that can work. I think it's big enough. Don't imagine it would have that much current usage. Whoop. Hitting the darn microphone again. Cables under the desk. Oh, I'm gonna have to get a stand for it at some point. Actually, I think I got a piece of tape that I can use to keep it up out of my way. There. Oh, now it's on the desk where my arm is. There, that's better. That connects over there. Trying to think here. Let's go back to trace 12. To there. And we got IO13 and chip select, which has to go all the way across. And an interrupt. What does interrupt connect to? So interrupt connects to the solder pad, which goes across to there. Okay, so bottom connect and via to the pad. Okay. Via to there. Let's give it some more space. Because I can, I'm going to give that more space. And I'm hoping ground fill will go in between those. If not, I'll space them some more. I want to fix these. 18, 17.5. actually, rather than trying to run this all the way around like I have, what I can do is actually move it over here. Traces can be more direct. I still have to figure out if this reset line is actually a reset and not something that's supposed to be controlled via GPIO, which I'll find out once I get my module in the mail. Okay, that's Ethernet wired. Power regulators wired. Let's try putting the buttons back in place. Would it work better like this? Looks like it. Oh, let's go back to Mills. And let's reset. That's gonna have to go under, and so will this. Let's go back to 12. And there we go. I got the programming header connected. I think I can get away with moving the buttons over slightly more. at the very least, also moving that slightly. Nope. There. And let's rip this up. Oh. There. So now there. And the reason I'm keeping the underside short is so that the ground plane can fill as much space as I can get it to, just to limit any potential issues. And so like this I can move over. Could actually pull it down. And they're on the same type of connection. And I'm actually going to put in another one of these big vias with a better trace on it for the ground of the ESP. I think that's the only ground it has. And then reset my vias. And then pull down, pull ups, and now I can, let's pull these. Make them even shorter. And this is all 5 volts. I'm gonna have to connect it over here, but for the moment, nope, too large. It's a good size. I'm gonna do the same thing . That I did. should give me some space for vias. Or at least better spacing for a via to fit. So, channel 2 can come this way and connect. Channel 1, it's best to do that, and then channel 3 comes all the way over here. So slightly unnecessary, but I think it's better. Now channel 4 actually has to go on the other side of this wire, so might actually work in my favor slightly. That's gonna need to be fixed. But channel 4 pass it through a via. Connect, and then now channel 5 is here, 6 is there. So 5, 6, let's try and change that around. So, no, 5 and 6 are backwards. There. Now I should be able to run traces right across. There we go. Now, these could all be increased. Change width 32. Yeah. Because I have the board space, why not? I think I have the board space. Let's go one size smaller. Change width 24. There. That looks a little more appropriate. Nope. Do. Looks good. Got everything traced out, I think. Now, this big spot here I'm realizing what I can do instead is a polygon. Polygon, no thermal. Let's change the width to 5. And we're going to put it on the bottom layer. And what I can do is trace out a really big section Now, let's see. I've got a really big power trace coming all the way up, and I'm actually going to change this. Now, ideally, make that with angles. Ooh, no. Now, I like avoiding power near bolts, so I'm going to move that away. Now, this isn't going to be as thick as I want it, so let's move that over. And let's rat nest it and see how we did. Yeah, so it's still moving around it, so move that, move that, move that outside of that. This is okay. Let's move it down a bit. And let's fat nest it. There we go. Let's fix this corner. That looks a little better. Let's nest. So it fills it in as one giant trace. Let's go a little higher, and I'm gonna go a little wider because I can, And the only thing left is this NeoPixel line, which comes all the way over to here. So top 24. Yeah, I think that was the only thing missing. And should actually double check which WS2811 I used. 'Cause I'm wondering if the footprint is right. Maximize the size of that trace, and let's find those LED drivers. Looks like I mixed up a few of these items in my boxes. Nope. Of course, it's got to be in the box that's at the bottom of the pile. Oh, no. Did I really mix up my boxes? Not that one. And it's definitely not that box. So let's see what box it is. I think this is the right one. Yep, looks like it. Now, I'm looking for this one. Okay, so the ones I have are SOP 8. Now this says SOIC. So, let me find a part that is the right size. SOP 8. So this should be the right size. So let's just confirm. How do we do? Oh, it's the right size. Cool. I'll probably do a one-to-one printout on my inkjet printer just to confirm. But good to double check nonetheless. So, the only thing now is what I can do. So I can polygon these power traces, and I'm gonna have to polygon probably want to polygon ground, but it's gonna try and fill in a lot of these spots that I really don't need it to. Let's change the width. These traces. Mostly because I can. It doesn't hurt to do so. I find the Fab House has a better chance at doing these pads when the wires are almost straight off and not doing anything funky. It's something I noticed recently. Yeah, okay, so that can stay, that can stay. Pardon me. So, rip that up. And air wire. Wait, did I order any of these power jacks? I don't think I did. Should figure out what part that is. Description. Let's get a bunch of these on order. And good. More parts ordered. Goodness knows I can't order enough. And I'm being very facetious about that. I'm ordering way too much. I did not expect to order this much this month. Trying to save some money because I do want to build a desk. But I need parts to send a shipment out to someone, and yeah. I want a little more space here, so I'm gonna move this over. Okay, let's go back to the other setting. So when I'm right clicking the grid and clicking last, it's going back to my last setting, which is mills. I find it a lot easier to sift through placing parts in the millimeter grid as I'm aligning a lot of these parts. And then trace width, I'm much more familiar with sizing in the mills, which is why I keep switching back to it when needed. Now, the whole reason I did that is so that I can do a polygon and fill more space in here for power. Set the width. I'm gonna leave thermal off. Okay, let's clean this up a bit. That should fill that whole section. And then I'm gonna ground fill. I'm gonna polygon for this 5-volt rail as well. Rip up signal. And then polygon. Actually, that's gonna turn off. Yeah, okay. That should give plenty of capacity for the 5-volt rail. It's really overkill for 5 volts, but you can have such a high input that, because you can make the board in one or two ways. You could get rid of this 5-volt circuit and change these 100 ohm resistors and run it at 12 volts and everything would be happy. But if you wanted to go higher than 12 volts and use, say, a 24 volt LED tower, well, you got to change the 100 ohm resistors and it's not very user friendly. So by putting the power supply here, everything's copacetic no matter what you choose to run on it. In terms of what you're trying to light up. Minimum would be, say, like 9 volts for the system to turn on, though. But you wouldn't be able to use a 5-volt LEDs without bypassing the circuit. This really is overkill for 5 volts, but meh. The 3-volt system, that's where the plane will probably become a bit more useful. So that's done. I'm gonna have to put a ground plane in. So let's see here. Polygon and my way around. lots of this is probably unneeded. Especially this section. This is just going to... Although, granted, shouldn't have any issues powering the Ethernet module. Hopefully. It's the whole goal behind this is, rather than a single trace, it's got lots of space to flow the electrons. Is it excessive? Probably. So let's power, and ground I can leave there. That's not going to cause any issues really. But the ground on this should have a polygon. And I'm going to turn thermals on for that because of how big these suckers are. I'm not going to get ground there through that, so it's going to have to be on the bottom side. We're nearing completion, which is good. This is a long stream. What are we in? Like 5 hours in? Wait till I start doing USB 3.0. Oof. That's gonna turn into one heck of a project. It's gonna be fun though. Polygon. Right. Should make for a really nice ground fill. Need it via here. Need one there. And all of that's connected. Actually, this spot can't hurt because it's just ground. Wonder. Just for the heck of it. Connect that to that, and should give me a nice ground plane connecting everything without thermals, with thermals attached. So, now it will automatically clearance everything, or at least it should. So I'm not too worried about these lines being close to each other. It should keep the polygons away from each other. The only thing left should be ground all the way around, but let's turn off top and bottom, and I could do dimensional. Turn off the bottom again. So I'm gonna do these rounded corners. Millimeters, 0.5. So that's 1. Ooh. 0. It's 1 millimeter, 2 millimeters. That's 2 millimeter rounded corners. Standard. So it's still showing a bunch of traces, but those should go away once I do the rat's nest tool and it fills in all the polygons. We'll find out soon enough. Yeah. Looks like right now it's just trying to fill in certain traces. So, last one, polygon on bottom. And let's go back to the mills setting. So 5. And ground. So, if that all worked, rat's nest. And so the problem here is it's trying to fill in over this. And that's not what we want. So so you got thermals here connecting things. Got a nice big power fill. And I can probably put some more space between some of this, to be honest. So, for ground, let's try this polygon again. Change to that tool. ground. So now that should not interfere. Rat's nest. So now it doesn't interfere with the power trace, but we get nice. Now I'm probably gonna upgrade these to connect to each other and get slightly bigger tracing. Now I don't need the lack of thermals. Now type in command via apostrophe GND apostrophe enter, and I get some vias for ground. I can use this to help bridge certain spots. The reason I'm doing that is I can add some extra tracing. I still want the thermals, but a little bit extra doesn't hurt. There. All the way wrapped around is what I want. It's pretty much what I want. Let's see if I can't get a slightly finer resolution on that. There. That was. Let's change the width. Should be 50. There. Now, if I hit rat's nest, fills it in a bit more. Don't really need to do more than that. This is gonna bug me. So let's fix that. Actually, this is really gonna bug me. Split tool. Split. Does it hurt to fill this with ground? That fills all of that in. Not worried about any of that. Oh. Wait, is that resisting down there? Yeah, okay, so I have restrict under there. Cool. So it's putting no ground fill around there, which is what we want. And move that label. All these labels have to now be done up. But I think I have everything the way I wanted it. Do zero thermal around that. Polygon. Oh. G&D. Let's do bottom. And rat's nest, that fills that in. It's covering those. G&D. Rat's nest. Good there, good there. Oh, missing, and rat's nest that. So we're not getting full ground around that, so let's move that around, and we can move that over. Rat's nest, and that fills ground everywhere. Ground is getting through there. Oh, not getting over here. Rat's nest. Okay, getting through, getting through. Oh, not over here. Rat's nest. Yep, yep. Think that's everything. Let's view bottom. I think that's everything. Yeah, a full connection everywhere. Let's run the DOC, because I know it's gonna find something. Yeah, okay. So top, go from there to there, and then 24 from here to there. Clearance. That's a simple one to fix. Move that over. Wire stubs. Oh, I hate these ones. These ones crop up everywhere. And then 12. There's one there too. Okay, so rip up. On the DOC again. No errors. Awesome. That's what we like to see. Now, here's a ground plane there. So, let's run the via command again. Let's connect it. I'm going to do the same over here as well. Oh no, that's not ground. I'm going to fill this in then. Let's see here. Move. And split tool. And then for this, connect that like that, and then rat's nest fills it in. Run the DOC again. Still no errors, which is what we want. think we're good. Got everything in place. So, the only thing left is labeling. So, let's turn off top and bottom. Let's go through and label things. And the values are showing. There we go. Labels. Oh. RN, caps lock RN3. Let's change our sizing. Now, part of the reason I do this is because not all the values will actually show up if I transfer it to Fusion 360. And I do like knowing values for things. LM 2596 S 3.3 2.3 volts. So at least this way I can pre-screen it before the fab house makes it, and I can ensure that it's the way I want it to be. I'm going to move that there. Actually, I just put those in the wrong spot. Let's delete that. Can leave the capacitor designator straight as text C1. C5 680 UF 35 volts. Same for that one. This one is 220 UF 6.3 volts. C2, C6, and you got 30. Move The reason I'm not going to put the value for those capacitors is I typically don't put values for the 0.01 and 10K resistors. Remove. Ooh, jeez. Now, what else? These need naming. And then delete, remove. Think that's everything labeled. I really shouldn't have ground here. Yeah, I guess if you wanted to power something externally, maybe. But it really won't be used because you'll be using this and then VN. Unless you're not using the power jack. Speaking of which, put my order in. I want to check something. I am curious. What the spec is. Oh, 2.5 amps by the looks of it. Which is kind of annoying. Tells you the contact resistance initial, withstanding 500 volts, AC for 1 minute, insulation, hints at being rated for 2.5 amps and its titling. Yeah, 2.5 amps at 24 volts. Which is where you can use the terminal jack instead, because the terminal jack can withstand a lot more. Although I am curious if they sell a higher current rated one. Wait, inside contact is 2 millimeters? Well, I hope it fits, because that doesn't look like the right size. It should be, but it says it's 2 millimeters. going to suck if I bought the wrong type. Granted, it's only $4, but even still. Let's look at the drawings. 6.5 millimeters outside diameter. Center pin is either 2 millimeters or 2.5. No, I do have a couple panel mount ones, so let's pull one of these out and see how it measures up. Zero and millimeters. This measures at 5 point. It measures just under 6. Well, it says 5.57. And it is zeroed. 5.4 is what that socket comes in as. The inside is measuring pretty large. .6 on the inside. I don't know. I think it's gonna be a bit of a gamble on this connector then. To wait till it shows up to find out if it's the right size or not. Well, I know the footprint matches my thing, but whether or not the power socket fits properly is going to be another question. Outside contact diameter, 5.6, apply. 5 amp power jack. Wait, what was that outside? Yeah, it's 5.7. Yeah, I think I ordered the wrong connector. But it's hard to say. Well, going off the spec sheet, I ordered the wrong connector. But it says it's 2 millimeter through hole, 6.2 millimeter. 2.1 millimeter jack LCSC. Yeah, 2.1 5.5. Definitely think I got the wrong one. There's this one from Acer, and let's see what it's. Where's the spec sheet for it? Weird. I don't see the PDF for it. Let's see if I can find a different one. It's very potent. Data sheet. There we go. 6 millimeters. And then this one says 6.5. Yeah, I think I got the wrong size, which is annoying. 5.7, yeah, that'd be toleranced. 0.3 of a millimeter tolerance sounds about right. So, just to be safe, let's see if I can't get a connector at 6 millimeters. I really can't tell. Because it's giving me quite a few options. Wow, a power socket with 7 amps. Capable. Whoa. Don't see that very often. At least not in these 2.1 millimeter jacks. They have like a few options. They don't look like drop-in replacements, so I'm just gonna wait and see what comes in the mail for the connector, and then I can adjust as needed. Because the ports will come way before the circuit board, as I have other projects that will take priority on circuit board ordering. The only reason I'm ordering ports is because I already have an order coming, and it's cheaper to just add them all onto one order. I think I've already purchased like $200 some odd worth of ports. Yeah, so all the labels are in place. Let's turn back on top and bottom. What I want to check is these regulators. That label I can put there. This label, I can put it there if I move this diode. rat's nest that. Oh, almost. There we go. Let's get the split tool. Let's rat nest that again. There we go. Might as well as ensure got the best connection. Via GND. Nope, spelt it wrong. There. That will tie it together and make sure that it has adequate connection. I think that's all I needed. For now, at least. See if any revision stuff has to happen. Leave ground up there. Everything else looks fine. All the values. Got mounting holes. I think I'm pretty darn covered. Let's run the design check, no issues. Nope. Delete. That's what I'm trying to delete there. Input range. You got 9 to 35 volts. And the only thing missing is logo. Output. Find my library. Now, I already know of a few things that I think will change in a revision. With Ethernet control, I have a feeling I'm going to run into issues with the interrupt and the reset. I have a feeling reset is supposed to be controlled via GPIO, not connected to reset of the MCU. Interrupt, I'm worried about it pulling the I/O line and causing it not to reboot correctly. So if I run into that issue, my intention will probably be to put in an MCP, likely the 08, because I don't need... no, I'm going to need input and output, so I'll probably actually end up having to use... oh, mind fog. The MCP 16. That way I can have input and output, and in terms of input, my thoughts would be to add buttons. So you could have it as a control panel using the quick connector. You could add like an LCD, a display, and then you could actually have some buttons on it if you wanted. So, got my logo, got my company name, tower controllers, then gonna be the name of this product, and the version code. Once I produce one, the code shall change. Save, and I'm gonna push it to Fusion and then post a screenshot online. So, have a good evening, folks.